I'm Willie Choi. I'm in charge of training with Doosan. I'm doing the hydraulic training for the training. So today, I would like to introduce about the flow control concept and what kind of the flow control does Doosan use and what is the future of the flow control. So before starting the flow control, I would like to ask you something. What is a flow control? Flow control. That means control of the flow amount, right? In case of the water pump, when you have put the plug, at the time water pump is rotating, right? At the time the water comes out. I'd like to reduce the the water. How shall we do? Is there installed some cork? It's okay, but we have some special device on the pump. At the time we can reduce the flow. Excavator also same function like that. Even engine is starting, at the time the pump discharges the big amount of oil. But sometimes we don't need the big amount of oil. How do we reduce? There are some device and we use the flow control. So for example, the machine work. At the time, what about the pump? Does pump makes the big flow or small flow? Machine doesn't work. At that time, what about the pump? Does pump makes the big amount flow or small amount flow? Let's think about that, okay? So, Doosan has the total 4 kind of the flow control. The first one is Negacon. Second one is Pogicon. Third one is LS. Fourth one is VBO, is new machine. Let's go the first slide. 자, I'd like to explain about the Negacon system. 자, this is a schematic of the the simple schematic of the Negacon system. Main pump here, main controller here, cylinder actuator here. 자, first one, the main excavator hydraulic system of the Doosan Infocora open center MCV plus and the flow control pump. The first one is open center MCV. This is MCV. So when you see this line, actually this line is open to tank. This is open center MCV. Flow control pump. The pump is here, right? But the pump discharging flow is variable. Sometimes small flow, sometimes big amount of flow. The pump is variable discharge piston type pump. As I mentioned you, the pump makes the flow. Sometimes too much, sometimes small. While engine is rotating, what about the pump? Does pump makes the big amount? Small amount? Depends on the working condition. Sometimes the pump makes the small amount. Sometimes the pump makes the big amount. And then next one, this one. The control valve, right? Basically the control valve. For example, no working condition. At the time, what about the spool? Spool is clogging. This line is clogging. This line is clogging. So cylinder doesn't move. But when the operator moves the joystick, the spool is shifting, right? At that time, this line should be open. This line also should open. That's why the cylinder is slightly moving. But the center bypass line, because center line, it should be slightly clogging. So once again, the spool shifting at the time, this line should be slightly clogging, this line should be slightly open. Alright? And then this one, cylinder, right? When cylinder get the flow at the time, the cylinder is moving, right? So now I would like to explain about the flow control. As I mentioned you, this line is slightly open, right, at the normal condition, at neutral condition. But spool shifting at the time, this line should be clogging. So let's think about this line, pressure. So now it's open. Even there are small orifice here, right? Open condition. What about the pressure here? Pressure is, low pressure, right? Because this line is open. Even there are small orifice here. So for example, the spool is shifting. At the time, what about this line? No more pressure, no more flow here, right? At the time, what about this line? This line is very low pressure, right? Anyhow, the pump takes one of the dot line, this signal from the MCV. At that time, the pump knows whether spool shifting or not. If spool shifting at the time, this pressure should be lower. Neutral condition, at that time, what about this? This is open, but orifice here, small pressure is maintained here. Anyhow, the pump get those kind of the signal from the MCV. That's why the pump know how does the operator know, how much the operator know about the flow. So finally, flow control of the Negacon main line is this one. The pump always sensing this line. The flow is depend on this dot line pressure. For example, the machine operator move the joystick at the time, spool shifting, pressure going down. At the time, the pump recognize spool shifting, right? At the time, the pump makes more flow. Neutral position. At that time, pressure should be high. The pump no, it doesn't. That's why the pump makes a small amount of flow. Let's see, relative of the stable, but the relative large of the energy loss because of the open. That's why the pump makes always flow. At the time, this is always goes to tank. That's why small energy loss is here. Right? Anyhow, the Negacon control. What is the Negacon control? I'd like to show you about some graph. I'd like to make some graph here. So once again, this line, P, and then Q, flow. So when we are checking the pressure of the flow, at the time, now neutral position. At the time, the pressure is high pressure here. At the time, what of the flow? Flow is low. That's why this point. When spool shifting, this pressure is going down because of the line is clogging. This pressure is going down. Pressure is going down. At the time, what of the flow? Flow should be increased. That's why when you make the line, this kind of the graph. So negative curve, right? That's why we call it negative control. So do you understand about the negative control, Negacon control? If you understand Negacon control, and then we go to the next one, positive control. All right? The positive control. Actually, we use the 70 tone and the 17 tone and then 70 tone machine. And also same like this, open center and then flow control pump. But one thing more, pilot shuttle valve. Almost similar. One main pump here, main control valve, a cylinder here. It also center line is open, but there are no orifice here. For example, the operator doesn't move the joystick at the time, spool is in neutral condition. At the time, the discharge oil goes to the tank. But this line is clogging, so cylinder doesn't move. When operator move the joystick at the time, the spool is shifting. Actually, this line is from the joystick. So spool shifting at the time, this line also clogging. And also, this line is slightly open. So discharge oil goes to the cylinder. Finally, the cylinder is moving. Actually, this is the main pump, right? It also takes some flow control signal. Previously, Negacon, the flow control signal is dot line from the MCV, but Pogicon, the flow control signal is from the pilot shuttle. Actually, this is a pilot joystick line. When operator move the joystick, the pilot pressure is coming to the shuttle valve and then connecting to the pump side. At that time, pump know whether the operator move the joystick or not. So, if the pump get this signal, at that time, the pump know how much big amount oil discharge or how much small amount those machine need, one of the signal. So what is Pogicon? I'm going to explain about this once again. This is a pilot shuttle, right, from the joystick. So we compare the joystick pressure and then flow. For example, neutral position. At the time, what about the joystick pressure? Almost zero, right? At that time, pressure is zero. What about the flow? Low flow, like this. When operator move the joystick at the time, pilot pressure is increasing, right? Increased pressure is coming here at the time, the pump makes the flow. High pilot pressure. At the time, what about the flow? Flow is increased, right? So when you make the graph, this kind of graph, right? This is, we call it, this is a positive curve, right? That's why we call this is a Pogicon control. Actually, Negacon, Pogicon almost similar, but different thing is, there are no Negacon valve, and then Negacon signal is different, right? This is Negacon signal. Sorry, this is Pogicon signal from the shuttle valve, but Negacon is from the control valve side, like this. So you got a point about the Pogicon control. If you understand the Pogicon control, at the time I go to the next LS control. This is a schematic of the LS system. LS system consists of the closed center MCV, flow control pump, closed center MCV. Previous Negacon, Pogicon is open, right? When the pump discharges oil at the time, the oil goes to the tank side. But LS system, even the pump makes the flow, the oil does not go to the tank side. It is a clogging line. That's why clogging center MCV. The pump is also same, the flow control. Sometimes it makes the big amount of flow, sometimes it makes the small amount of flow. LS means load sensing. The pump always takes the cylinder side of the load through the LS signal line. Basically, the pump makes the always 20 bar higher than LS pressure. So for example, now this pressure is 20 bar. At the time, now the LS pressure is almost zero. That means the spool doesn't work, right? At that time, the LS pressure is zero. At that time, the pump pressure is this side of the main line is always 20 bar, a little bit higher than 20 bar higher than LS pressure. So we call it, this is delta P. Always the pump makes the 20 bar delta P when compare the main line and then LS signal. So for example, the cylinder is working now, right? So this pressure is, for example, 100 here. At that time, the pump makes this pressure 120 bar, 20 bar higher than LS pressure. So for example, cylinder LS pressure is going down, maybe 80 bar. At that time, what about the pump? Pump makes the 20 bar gap, right? At that time, reduce the pressure. How? How we reduce the pressure? Reduce the flow. The pump reduce the flow. At that time, pressure should be reduced. That's why even 20 bar gap at that time, the reduce action will be stopped. So for example, the cylinder moved like this. What about the pump pressure? It should be increased, right? How much? Higher than 20 bar. How do we increase the pressure? The pump makes the flow. So more flow, and then 20 bar gap at the time, stop. No more discharging flow. That kind of flow control does pump use. Once again, the LS system, the standard pressure is, the basic pressure is LS. Always some specific value of the higher pressure maintained by the pump. How? Flow. Reduce flow, 20 bar. Increase flow, 20 bar. Stop like that. This is LS system. That's why low energy loss due to the low oil go to the tank. The pump discharges always demanding oil to the cylinder. No more tank. That's why energy loss is very low. Once again, the LS system, the basic signal is LS, right? Load sensing signal. Always specific value maintained. Cylinder pressure is like this, reduce flow like that. Cylinder pressure increase at time, increase flow like that. 20 bar gap. This is a key point of the LS system. Alright? So if you understand about the LS system, we're gonna go to the VBO system. This is a VBO system. Concept of the closed center MCV, same as the LS system, right? The line, center line is actually this is no center line. Actually, this is a clogging. And also pressure control pump. It also pressure control pump. Sometimes the pump makes the big amount. Sometimes pump makes the small amount. But little bit different thing is control way. Alright? So for example, this is a schematic of the VBO system. What is this? This is joystick, right? When operator move the joystick, at that time the pilot signal goes the control valve, spool may be shifting. But one of the signal, this is what it is. This is a pressure sensor. Pressure sensor, right? The signal goes to the pressure sensor, and pressure sensor gives the signal to the controller. We call it this is FPOS. When FPOS get the signal, at the time, FPOS give the signal to the main pump. But the main pump has there are no physical some hydraulic the signal line. Actually, the main pump has the one EPPR valve. EPPR valve gives the pilot signal to the main pump to increase the flow or decrease. Anyhow, the main control, main pump takes some signal from the controller, FPOS, to the EPPR. So finally, EPPR gives a signal to the main pump and then increase or decrease. Actually controlled by the electrical, not physical pilot line there. Basically, the VBO is very important of the controller. The EPOS know, the controller know what kind of the operation by the operator through the pressure sensor. And also, EPOS keep the signal to the EPPR. How much does main pump decrease or increase the flow to the cylinder side? Basically, all controlled by the electrical. That is different with the VBO. That is different with the Megacon, Posicon, and LS system. So, do we understand about the Posicon system, Megacon system, LS system, VBO system? Today, I'd like to explain about the 4 flow control system. Megacon, Posicon, LS, and then VBO. If you want some more information, if you want to know something more at the time, please mail me. Alright? Next training, I would like to explain about the Megacon system, some more detail. Thank you for joining today's training.